When a light ray is incident on a medium, it will either reflect, refract, disperse, or be absorbed. And today we're going to talk about what happens when a light ray refracts through a lens. So when light rays hit a different medium, they will bend depending on the index of refraction of the medium. Or another thing that can affect the way a light bends is when it goes through a lens. And so we're going to talk a little bit about ray diagrams and how they show the way that light bends. And from ray diagrams, you'll be able to tell how the light bends, the resulting image location, size, and orientation.
Poetry. Alright, so this ray diagram depicts how a diverging lens affects rays and with refraction. So when drawing a ray diagram, we usually use 3 rays for representation. And since it's a diverging lens, the first ray comes out perpendicular to the object and then refracts in such a way that it lines up with this focal point on the same side of the diverging lens. The second ray goes through the focal point on the opposite side of the lens, and then the third ray goes straight through the center of the lens. So when finding where the image will be, you look at where the 3 lines intersect. And here, a converging lens, you draw the rays a little differently. So the first one comes out perpendicular to the object, hits the converging lens, and goes through the focal point on the opposite side of the lens. The second one goes through the center of the lens, and the third one goes through the focal point on the same side of the lens, and then refracts perpendicular to the axis. The image then is where the 3 lines intersect again.
One real-life example of lenses are the eyes. Eyes act as a converging lens, with a focal point being on the retina. This is what allows us to see images. Sometimes, eyes don't work correctly because the focal point is located somewhere other than the back of the retina, causing near and farsightedness. This image shows an eye that is nearsighted, meaning the focal point of the eye is before the retina, so people cannot see images that are far away. If the focal point were to be behind the retina, the person would be farsighted. In order to correct this issue, this person would have to wear glasses or contacts to force the light rays to bend into the correct focal point. For nearsightedness, a diverging lens is needed in order to correct the focal point. This is because it will cause the rays to slightly diverge before hitting the eye, so then the eye can make them converge to the correct point at the back of the retina. We can see here how this lens makes up for the eye's irregularities.
Another issue that can occur is that the cornea of an eye is misshapen. This is called astigmatism. A normal functioning eye has a cornea shaped like a baseball. However, people with astigmatisms have corneas shaped more like a football. This irregular curvature affects the angle at which light enters the eye, which causes the light to bend incorrectly to create an image. Instead, light converges to multiple different focal points, causing blurriness. It is commonly believed that the only part of the eye that focuses light is the lens. However, the cornea and lens work together to focus light rays, which makes having astigmatisms a larger issue. In fact, the cornea possesses about 80% of the light bending power of the eye. The cornea surrounds the eye and has an index of refraction of about 1.376. This difference in index of refraction from air to the cornea is largely what causes light refraction. After the cornea, light hits the aqueous humor, a watery liquid that surrounds the lens with the index of refraction of about 1.336. This is not a huge difference from the cornea's index of refraction of 1.376, which is why most of the bending happens from air to the cornea. One way that astigmatism issues can be corrected is through LASIK surgery. LASIK surgery is used to correct the shape of the cornea so the rays bend correctly and to the correct focal location. Since most of the refraction happens in the cornea, fixing it can solve many visual issues. The first step of LASIK surgery is to use a laser to create a flap in the cornea. Then, laser bursts are used to reshape it. Once the shape is fixed, the cornea flap is closed and allowed to heal. Once the cornea is correctly shaped, the light rays are able to bend in normal fashion to the focal point at the back of the retina.